The graph neural networks has so many applications, but like I highlighted earlier, one of its application is in the area of social networks. Now, like I said, when you looked at the social networks, which we have them all around us, and I give you an example of Facebook, LinkedIn, Instagram, TikTok, and all that, you can use this information, although there are lots of privacy concerns, so most times they won't give you information. But I think Twitter, you can be able to analyze some tweet if you have some permission. I think you could be able to request, but I don't think Facebook does. Facebook is kind of difficult. You can be able to analyze the user's behavior, to make prediction or friend recommendation or even community detection. Now, let me tell you, this is where I keep saying that Nigerian security architecture, African sort of policing needs to improve. Because I listened to the EFCC boss some days back, and he was talking about how the Yahoo fraudsters are blocking a lot of investment and all that from coming into the country. Investors scaring investors away. And then he also talked about politicians that are storing money using Bitcoin and all that. So, but when I listen to him, he talks about so much stuff and all that. But again, I still see this um technical know-how that is absent. And I'm not saying they are not doing their job, but they need to begin to employ this kind of technology to be able to detect this crime even before it happens. And that doesn't mean you can 100% eliminate crime from the society. It's difficult, but to a large extent, you minimize these attacks. How will you do that? Is by looking at the networks of these suspects. Now, definitely organizations like EFCC, the police, and all those things, they have this suspect list or wanted list. Now, when you have them, you can analyze the social web information. Now, that web of information that is available on these platforms can be able to give you a lot of hints about their behavior. It can give you information about their close pets or who are the people that they are working hand in hand with. Because the social networks has this carbon print of these people and they interact. I see the the what do we call them? Herdsmen terrorists sometimes coming on TikTok to make comments and all that. But yet the security looked away from these things. But you can be able to analyze a lot of things. You can pick a lot of information, a lot of carbon prints from these videos, from this kind of things. And it can be able to inform decision intelligently and help to curtail this thing. And I think in one of our papers that we did sometime 2021, 2022, which I think I spoke in one of the conference of the Statistical Association or something in Nigeria. I make emphasis on how the security architecture could change by harnessing big data. And this social network is a very good platforms where you could be able to analyze this web of information and be able to inform decisions intelligently. So we can be able to detect a lot of things from mining these tons of information online, and it will help us to, save lives. Now, it's not just in the social interaction networks alone. In areas of drug discovery and bioinformatics, we are using it a lot. I remember in my PhD work, one of the tasks I needed to do was to find viable drugs for COVID-19 because that period, the vaccine was not yet out. So we're looking at drug targets, potential drug target. So when we analyzed from the genomic whole exome sequence data set, we were able to identify this subpopulation of patients that were suffering critically from the disease, if despite that they were young people. So what we started doing next was to look at the profiles of these patients. When we looked at the profile of this patient, the next thing we now started doing to look at which of the genetic variants of this patient were, for example, upregulated or downregulated. So by the time we identify those substable genetic variants, we now started looking for drug targets for them. Were there any drug from the bioinformatic repos and pathways that we could be able to. So we looked at the biological pathway to see what sort of pathways were coming up. And then we now begin to use what we call phenome-wide association study to look at if there are kind of diseases that are linked to those kind of diseases that we're seeing from those pathway signalings. Then from there, we now begin to look at the drugs. So those kind of drugs have already been approved. So it could easily be repurposed and helped this kind of patient. So the graph neural networks could help us to be able to do that. And even if you looked at my PhD work, and I think I could share it with you guys, but I don't know if you could actually see my screen. I could have actually shown you guys what we did. Anyway, let me probably at the end of the class I could show you guys because I don't want to take the screen off. So you can analyze publications, protein pathway drugs, cells, and so many others, even diseases or genetic variants to identify these potential drug targets from looking at the protein structure. You could be able to make this prediction. Now, another very important area is the recommender system or the recommendation systems where we make recommendation based on these shopping preference, movie, and all that, like Netflix, for example. Most of the time, if you use Netflix, you see it will recommend movies for you, most likely based on what you have been watching. So if you are watching more of the Vampire Diaries or something, you are likely going to be seeing different movies in that category will be coming up. If you are watching things Game of Thrones, you are likely going to be seeing movies in that category coming up. If you are watching all these love series and all that, you will likely see more of those movies recommended to you. If you are a type that watch more of faith-based religious sort of movie, you always see those kind of movies also recommended to you. So it will recommend movies for you based on that. And then another, again, it could recommend movies to you based on what people are watching in your region or in your country. So most times, if you are maybe in the US, you're likely going to be seeing movie popping up based on top movies that people were watching for that week. There was this movie I saw last time. It was I think it was a movie from 2021, but it didn't really go viral until recently, where something happened and people that watched the movie started talking about it on social media. So and I'm trying to remember the name of the movie actually. So when people started talking about it, a lot of people now started going back to go and watch the movie, to see what these people were talking about. So stuffs like that. So sometimes you can see movies that were even completely forgotten about. I think during COVID, there was also this movie that talks exactly about what we saw during COVID. In fact, it was like those guys were in the future. I'm trying to also remember the name. I'm not really a movie fan as such again, but it was a very, even me, I was then I had to go watch that movie. And it's not French Science. I'm trying to remember the name. Either Back to the Future or something. But it's predicted a lot of things that we saw during COVID. So stuff like that. Most of these movies you'll be seeing them based on what people are watching around you. What other friends that you have are watching, what that country or that region is watching, and all that. You see those kind of recommendation coming up. Very important, fraud detection. Um, Again, I talked about Nigeria, and like I always say, one of the reasons I talk about Nigeria is not to criticize them alone, but to proffer solution so they could be able to adopt some of these approaches. Because I see a lot of people with technical know-how lacking that I feel, they need to start talking with experts so they could be able to make the system much better. So in area of fraud detection, Nigeria is not doing well. And the reason is because we fail to even differentiate between these fraud crimes and other form of crimes. So most of the time you see the police guys are the one at the forefront championing this curse, or probably an EFCC or ICPC. So there is a lot of this lack of cross-talking among the agencies. And then, so many bureaucratic processes and all that. Now, when we are looking at fraud detection, most of the time, AI has provided us with a lot of computational and technical know-how that we can be able to handle this detection conveniently. And this kind of detection comes with such a way that it minimizes a lot of false positive. So you won't be able to say, oh, you are scared to confront things, because it will analyze patterns. When it looks at these patterns, it could either be the call logs of those guys, it could be the social media platforms, it could be emails, it could be different information that are made available to some of the security agencies. By the time you look at this information, you could easily detect who is the victim and who is the fraudster. Every day, for example, banks and other financial institutions struggle with a lot of issues around cybersecurity threats. We are beginning, like I told you guys last time, that with the evolution of the large language model that we are seeing today and the agentic AI, the world is entering into a very deadly, dangerous phase where we begin to see a lot of threats from these hackers, because some of them are way, way advanced than even the people, the government and the good guys. So they are tweaking their approaches every day to become more complex and evict detection easily. So the government don't need to be using the same approaches that they have been using yesteryears. They need to begin to look into these technologies and employ them to be able to solve some of these issues conveniently and be able to rid the society from some of these bad guys. How can they do that? Employ things like graph neural networks could be able to help us to analyze this web of information. We can be able to look at this data that we have either in real time or sitting in databases of the security agencies. By the time we analyze this data, we can be able to pick up our patterns. By the time you pick up patterns, you can be able to know by that level of attention that is going to be assigned to each of these nodes. You'll be able to identify who their target suspects are and who is going to be their next victim, or who is in their radar, and who is even the person perpetrating the crime. So by the time you get that information, you can easily pass it on to the ground or foot level soldiers or the people that are doing the arrest to be able to go in and take out those guys conveniently. Because sometimes you see the EFCC guys raiding a whole hotel and arresting everybody, both people that are suspects or they are not. That kind of random search, without this level of precision. I saw a video one time that was making a lot of headlines where the EFCC raided the house of the guy. They said he's a medical doctor around 2 a.m. in the night or something, and the guy opened fire and killed either two of them or something. But when you look at that kind of accident could have been avoided if they are working with this level of information and intelligence. By the time you analyze this information, you could even know where that person is going to go to. You can be able to predict which kind of restaurant that person patronizes, what sort of timing, or even you can virtually have all the information of that person at your tip, because the web of information provided with a lot of carbon print that we could easily pick and be able to make our prediction conveniently. And at the end of the day, it will go a long way saving us resources and showing this level of professionalism. That's why you see that when you watch the video of how Hush Puppy and his gangs were tracked by the I think DIA or CIA, you would see this level of, how these guys were going about. They have to go get information, I think, from HP, get information from the network providers, analyze this information, and they keep monitoring these activities on social media like Instagram and all those Facebook and all that. They were monitoring what and who he was interacting with. They were able to do that until they were able to get to them and busted them and caught them. So we need to do better in developing countries like Africa. We need to step up, by promoting this kind of technology among our experts to be able to minimize this volatility that is happening in our financial institutions. So we talk about the Cybex that happened last time, not too long, where a lot of people were defrauded their money. If there was this level of sophistication in our architecture, we could have been able to mitigate those risks before it happens to those people. So one of the advantage of using the graph neural networks is that it's very excellent or do very well when we are modeling complex relationships that have dependency, because the normal traditional neural networks assume this independency. It always see these things as independent futures. So that sort of thinking by the normal convolutional neural networks and recurrent neural networks and so on help us not to be able to analyze these complex relationships, like looking at the nodes, the neighborhood of that node, and then establishing the relationship between the edges. Now, we also talk about handling non-Euclidean data. Like we said, most of the traditional neural networks like CNN and RNNs, we know that they work with structured data. Yes, you could think of it and say, but they work with images, which is complex. No, the image is divided into grids of pixels. So because of that, it's very easy for the convolutional neural network to feed on it, and then at the end of the day, zoom into places where it could be able to, add up these matrices, do some sort of transformations in the hidden layer, and then output if it's a cat or a dog or something. And then the same thing if we are using RNN, it's sequence data. So it's easy for it to move through it and be able to, know what's happening. But in the graph on the other side, it's not true, because the graph is kind of really complex. The data is dynamic in some sort. Sometimes it could come with maps. It could come with contours. It could come with different representation. Now, not just that representation, but the fact that everything is not just happening simultaneously. There are some regions where there are high density of activities. You will see a lot of connections around that node. And then there are regions where there are lots of sparsity, fewer connections. So it's not everything that is important. So at the end of the day, it's only the graphical neural networks that could be able to zoom in, extract this information at graph level, at edge, node level, and also at edge level. It's very effective when we are dealing with tasks that has to do with relational data. If you understand relational data, like citing your fellow authors in papers, or sometimes when you trying to look at how this pathway, like we said, from or biochemical structures looks like, you will get to realize that they are very, very organized. They are linking each other, or even a database. When you look at database and you know your SQL, you will see that the SQL uses that relational dependency to be able to pull out or manipulate or transform information. So it's kind of data that are relational in some sort, where we have the parents, the children, or something like that. It's easy for us to link them together. So if it's a link, a node classification, it's good at if it's linked, or even the whole graph itself, it could still be able to find patterns. However, nothing that it's devoid of challenges. So it also has its own challenges. It has its own limitations. So the graph neural network is not wuru. It has other issues. Okay. So what are the challenges? One of it is scalability. When we talk about scalability in this case, is that it has a lot of information. The graph is very large. It can be very large in some cases, which comes with a lot of uh, dimensionality concerns. And one of the problem in computer science is this computational challenges that comes with high dimensional or cost of dimensionality issues that arises. Most of the time, it arises due to sparsity. Like I hinted earlier, that some areas has a lot of density of things happening. Like if you look at this graph here, you see that it's not all, there are things happening here, there are things happening here, there are things happening and here, but there are fewer things happening here. So there is that fact that you could suffer from this sparsity. And you could see, even in this graph, if you zoom into it, you will see that it's not all the area. And this could be millions, even billions of connections. So that kind of connection, imagine now putting it as a matrix and you're looking at the adjacent matrices. You could imagine how large that could be and the time it could take for you to process this information. So the computational challenges, sometimes if you don't have this heavy computing facilities like GPUs, you will find it very difficult to be able to arrive at a result immediately. And that's one of the things you keep seeing with the neural network side of the story. It comes with a lot of computational challenges. And I keep telling you, when we start the practical section, some of it you will see, we will not be able to finish it. You will just have to allow it to run for maybe 2, 3 days or even more. So except maybe when you have some sort of computational facilities on cloud or AWS, or maybe you have some other private cloud facilities or even GPUs to help you to speed up the process. So that scalability could be a challenge. Now, the over smoothing. Most of the time, the deep graph neural networks can sometimes cause node representation to become too similar. And this is one of the problems, because since you are making prediction, it's something that you cannot be so certain. Okay, you cannot be so certain, so you could have a situation where all the things you are having look so similar. And how do you now say what is this and what is not? So that's one, again, that's why I'm an advocate of making sure you are working with domain knowledge experts. Because most of the time, especially these graph neural networks, one of the challenges you will face is lack of domain experts. If you don't have that domain knowledge informed either from literature, working with experts in the field to look at the data you have curated in the first place, you will end up just doing sort of things that has little or no impact on the scientific community. So always make sure when you are designing the architectures of this model, you have some sort of foreknowledge or insight of how these things should look like. That's what will guide you. And like I said, you can get that domain expertise either looking at literature or talking with the experts that are experienced in that field, that have already done something in that field, That way they can be able to guide you to arrive at a very interesting conclusion. Now, when we talk about the dynamic graph issues, most times when we are handling graphs that rapidly changes over time, we will have a lot of challenge because it's not static. Imagine when you are working on real time, and that's one of the challenge of big data because one of the V's in big data is velocity, and not just velocity, we have the veracity. So you could imagine this complexity streaming in at the same time. It could be quite problematic for you to be able to, capture patterns that are evolving rapidly over time. That's why things like weather prediction sometimes is very difficult because when you are looking at the information, they could rapidly change. And because of that, sometimes capturing that weather at a local level could be sometimes challenging, and all that. And I think I had a link to the full text in this paper I was reading, quite very interesting, highlight some of these challenges and issues around explainability and why we should embed some of this into the design or architecture of the model so you can look at it and explore it better. Now, in data science, we could use this graph neural networks pipeline. First, like I said, always tell you the ETL, the EDAs, very important. You perform your future engineering, and then the graph neural networks can help you to automate the future extraction phase, from the graph. So make sure the graph you are using, you have them all, maybe in one folder or something. Once you have arranged them, they are okay, then you can feed it will do the data extraction for you, the future extraction for you. Then the model training phase, as usual, you can split them maybe into 20, 80, 20, 70, 30, depending on what you want. And then you can use the graph architecture to be able to do either that classification, looking at the entire graph, or you are just you are interested at looking at the node, or you are interested at predicting the links or the edges. Okay. So depending on what task. And remember, it could be a classification or a regression problem at this case. And then of course, you can use the normal evaluation assessment in machine learning, which we talk of the accuracy, the prediction, recall or precision, the F1 score, the AUROC curves. You can use them to check if you can also look at the learning rates to see if your prediction is accurate to some extent or not. So the evaluation, you'll be able to assess the performance using the appropriate metrics for the graph tags. Now, in summary, we are able to look at what the graphical neural network is, and you could see it's actually a very powerful tool that can help you to analyze structured relational data by unlocking great insights that the traditional learning techniques could not be able to fine tune. Well, I think the future direction is we have to find a way to improve on the scalability and efficiency of the network, and also to be able to develop methods that could be able to capture that dynamic graph problems effectively. And then I think this is already in practice integrating the graph neural networks with large language models, which I think is already in practice because things like Google GNN and ChatGPT and all that, you will see what we call the mind graph. So that mind graph shows you this sort of graph representation of your ideas or information and how it's being done. So I think if we have any question, this is where we draw the curtain. So any question, feel free to ask.
Thank you very much for this section. It's quite wonderful, and for me, it's quite interesting. Seeing that it's a model I'm actually using any moment from now. I'm also already playing around with. So what is the difference between a static graph and a dynamic graph?
Okay, so static is like it's the name static. The state doesn't change. It just it's going to be the same data, and then you're looking at the input. But when we say dynamic, it keeps changing. Either it's changing in the process of time, or at each run, the arrangement will change.
That's the structures of the graph will change.
Yes. So either you're looking at the changes in the structure of the graph, or changes that happen because of the evolution of the events in time.
Mm.
Mm.
What's the
So like,
link with okay.
Okay, you want to ask something?
No, don't worry. Let me hear you talk.
Okay, so like in the case of fraud that I showed you guys earlier on the fraud detection network that I talk about, this is not really a static thing, because these guys are evolving. They are changing their dynamics and approach every time. So because of the way they are changing it, yes, you can look at the problem from two areas. You can consider it as static to learn what they have done previously, and then you could now use the dynamic to predict what they will do in the future. You see the thing? Because they are evolving. Like I told you guys last time that there is this proposal we have written, although it didn't go through. We are still going to submit it to another funder. We want to model this paper mill issue. So we discovered that these guys are attacking the problem from two different angles. One of it is they look for vulnerable data, like the enhanced data, which is very common in medical sciences. So they get those data because the APIs are free, the data is available with little restriction. So they get those data, they mass produce the papers. So they only need to tweak some changes, make some changes, alter some images, and then they could, the same person could have up to 5 papers using the same data. And then at the end of the day, the papers will go through again because they will use things like ChatGPT, large language model, to help them to write a robust paper. That if you're not careful, you will not spot any inconsistency. So, but when you look at it deeply, you will discover that there are some inconsistency in some of the things they do. Now, things that has to do with a lot of robust, for example, statistical checks that have to come with, let's say, multiple comparison tests. Because most of the time, we have this belief that if you have a lot of categories, there is high level of FDR that could come up. So you need to do some sort of multiple comparison tests to mitigate some of these challenges that will come up. These guys won't do that. Maybe they just go do a chi-square or do some sort of little statistical test, and then they stop there. So when experts begin to look into it, you begin to see some of this pattern. But these guys are not just stopping, because now they are evolving, they are changing. So with tools out there like deep research that is available in all the in all these large language platforms, they are now turning to those things to do those things for them. So they just need to get the research question, they need to get maybe the topic, they tell the deep research tool to do all those things for them, and they do it for them, and maybe with little or no supervision, they submit those papers, and those papers scale through. And we're beginning to see this trend skyrocketing since the ChatGPT came on board. So how, in that case, how do we mitigate them? You can look at the problem from two perspectives. One of it is to look at the previous failure, the previous pattern, and also the policies that were put in place by maybe the publishers, the government, and all that. Is those policies and approaches really robust to stop the existential threats? Then now you begin to look into the future. How do you now develop robust detection approach that you can be able to detect them? Because now these guys are evicting plagiarism checkers. They are evicting all those tools that are out there that are supposed to put them in check. So if you don't develop a more smart way to stop them or minimize it, like I say, you can't completely eradicate these things, but you could minimize it to at least embarrass minimum. So if you don't begin to think of how you can think ahead of them to be able to stop what the next move they will take, you won't have a problem because this thing is like a chess game. And if you know the chess game, if this person take a move, you need to be able to preempt that move in order for you to stop them. If not, you end up, losing your queen or your king in the game and that person winning. So stuff like that. That's how these things evolve. So the dynamic graph is difficult because you don't know the future. You can't really predict the future. The future is quite uncertain. So it's kind of really difficult for you to actually keep up with that trajectory. But again, like I said, working with domain expert would actually help you to be able to understand the problem effectively, and then you could be able to profile solutions that are, robust, to handle these issues.
That's interesting. Is it possible for me to there is this data set I have? Okay, we told you we were working on an ontology data set sometime. Even though we are still waiting to finalize the data, which I will use for our experiment, there is this data set I found that it's actually a graph, it's a structured data set. That's what we do in the ontology. And then it's quite going to be very robust with GNN training with GNN model. So I've been trying to pre-process the data set all along, but trying to give some. I've tried some point, and then when I try to correct something, I will just scatter the whole thing. If it's possible to have to test to use if we can use that particular data set for a practical on GNN, is it possible like that so that we can have a walkthrough through it? It's an OL it's an all format, so and it's a good input for GNN. So I could share you the link, and then we'll see how we can process it and see.
Yeah, it's fine. It's fine. It's not an issue. Once you have the data, I think it shouldn't be much problem, modifying it to your case. Yeah.
It's okay.
So I don't know if we have any other question from any other person.
Okay, doctor, well done, sir.
Yes.
So there's one small question I want to ask.
Okay.
So the neural network is capable of handling both structured data, semi-structured and unstructured.
Yes.